Hello YouTube, and today we are going to be going over variables, types, and just general stuff about Java more in depth in last tutorial. So last tutorial, I recall we went over just really basic, fundamental aspects of the Java programming language. In this tutorial, I'm going to go over more advanced stuff. I'm going to look at types from a more in-depth view, and we're going to do functions from more in-depth view, and if I decide that we should, we will probably do classes, and we will be doing enumerations. So, I forgot to tell you last tutorial, if you don't like the welcome menu, you can click that checkbox and turn it off. So let's go ahead and create a new Java project. And we can go ahead and close our project. If we want to use our code from our old tutorial, we could use that, but we probably won't be using that. So in this, we'll just go ahead and create our public static void main. And let's go ahead and start looking at types. So the types we had last was int, long, float, double, but just general stuff. We went over string, and we went over general types. No, we didn't really go on any in-depth ones. These are some very common types, and probably the most common. So, here's going to be a little list of more types. So you may, let's say a float isn't precise enough. Well, you can use a double. That's more precision than a float. Let's say you only are going to be storing one letter. Well, then you probably want to use a char. Sometimes your number might be so small that it's never going to exceed over 128. So we would use a byte. So So here's some of the other types, and here's some other common types you might see. So byte is not primarily used a lot, but well, I mean there are uses for bytes, but you won't see it in regular. Most of the time, you won't be working with just a byte. I mean, mostly you would store things as an integer because, well, computers have a lot of RAM. In particular, my computer has 24 gigs of RAM, and you can view your RAM on Linux by doing the top command. And as you can see, 24 gigs of RAM with 20 gigs of swap. So, RAM isn't really that big of a deal if your program uses up a lot of RAM. But if your number isn't going to exceed the maximum range of the variable you're using, then you probably should use let's say you have a number that only goes from 0 to 64. In that case, it would be stupid to use an integer because that's an extra 24 bits. And there's no real point in wasting that extra memory. So why not just go ahead and use a better variable? So all these types work like normal, but some of these types have special operations. We can add, we could subtract, multiply, divide. All of them we can do. Now, some of these types are numbers, some of these are text. And a car is very special. So I could say character letter is equal to 48. And then we can print letter. Hey. What? Okay. Close the level. And then let's print this out. And let's just see what happens when we create a variable and we print it. Well, we get a 0. But what? We set this to 48. Why are we getting a 0? That don't make a lot of sense. Shouldn't we be getting a 48? Well, if we refer to an ASCII chart, an ASCII chart is actually better yet. The best way to describe what an ASCII chart is to show you what ASCII is. So let's go look at every single value that we can have, every single ASCII value. So I'm going to create a for loop, which is just going to go through a range of numbers, basically. So my range is, I'm going to go through 48 to 128, and I'm going to add 1 each time. And I'm going to print that value. And maybe we should set this to print and not print line. So as we can see, we get this as our output. So this is just some character. This character, obviously Eclipse can't print this character right here out. So what it's doing is it's just showing you that little image telling you it don't know what that means. But if we look here, there's an alphabet in caps lock. And then there's the alphabet in lowercase. So a character is literally a letter, but it's the numeric representation of a letter. So if you have a string isn't really text. It's actually just an array of numbers. And the numbers are of type character. And we can represent this by So if I run this code, what it's going to do, it's going to look at the string test, and it's going to go from 0 to the length of that string, and it's going to find the character at I, this number I. Let's just run that and see what we get. Well, it printed out our string. Why did it print out our string? Because we're going through each of the characters and getting the character. So I don't think I've showed you casting yet, but I'll explain what this little bit means later. So here's the actual ASCII, every number in the word test. So every number in that string. That's the value of each of them numbers. As we could see, right here we have our two O's. Space, as you notice, is a 32. Also, if you notice, the actual numbers tend to start with like 100 or a high number. And then a exclamation mark is a 33. Symbols normally start at the beginning of ASCII. And alphabet. ASCII kind of has like... ASCII is really convenient in the fact that it's ordered in a very particular way. So, yeah. So as you can see, that's the ASCII representation. So now I'm kind of going to jump into conditional loops now that we kind of have an idea of what types are. So there are different types of loops, and so the very first conditional statement we have is if. If condition, then do something. And then with if, we have else. So I love how it don't see this typo, but it sees the other typo. So that's the most basic condition we can have. The most basic conditional statement we can have is if, else, if, and then else. And what that means is if this condition is true, then go ahead and do something. Otherwise, if this other condition is true, then do something. And then otherwise do something else. And this is really useful. And to be honest, you can do pretty much anything with that. So the next one we got here is while condition. And it's kind of self-explanatory. While condition is true, do something. So while a condition is true, it's going to do something. You can tell it what to do. And again, that can be done with if statements. And a bunch of methods. But we have a keyword for it. So all these can be done with if statements. Now for is a little special. So we have for a value in a range, do something. So for a value in a range, do something. And we'll go into detail of how we actually specify that. So let's look at conditional. There's another really useful one. That looks confusing, but so while a condition is true, do something. I'll go into the last two later, but first we're going to look at the first conditions, and we can look at the first two. So what do I mean by condition? A condition is of type Boolean, and if we remember, the Boolean is a true or false. And certain conditions you can have is greater than or greater than. less than, equal to, greater than, equal to, so that's some conditions you can have: greater than, less than, equal to, greater than or equal to, less than or equal to. And then conditional operations are a thing. So So, the conditional operations are a little special, but first let's go over conditions. So you have greater than, less than, equal to, greater than or equal to, and less than or equal to. And if you notice, the equal to sign has two equal signs. What's up with that? Well, simply, it's because how would the program know if you're setting a variable or if you're trying to see if two variables are equal? So to separate the two different possibilities, if you're checking to see if two variables are equal, it's two equal signs. But if you're trying to set a variable, it's a single equal sign. So that's why we have that. Greater than or equal to and less than or equal to are just for convenience. You can like write a whole entire program forgetting about them and use the conditional operators at the bottom. So if A and, so two and signs, B, that means if A and B are both true, then this is true. And then A, two lines, A or B. So then if A or B are true, then this is true. And an example of this is above. So as you can see, an example of this is if A is greater than B or A is equal to B, that is the same as greater than or equal to. So yeah. So now one thing we could do is we can start writing some code. So let's create a simple program. Now, in this simple program, it's basically just going to, you give it an age, And if your age is over 16, that means you can drive. If it's equal to 15, in some states you can get a permit. And then if none of them conditions are met, then you can't do either. So let's mess with this. So let's say our age is 14. Well, of course I can't drive or get a permit. If age is 15, well, I can get a permit. For age is 16, then I could drive or get a permit. So if we see we have that greater than or equal to, if we say 17, that's greater than, so it's going to say we could drive or get a permit. So let's say we want to add some more conditions on here. So if the age is greater than 0, so if our age is greater than or equal to 0, that means you can't drive or get a permit yet. But if our age is less than 0, for some odd reason, you can't exist. Which is pretty neat. And you could do some quite powerful operations with these basic if-else statements. Right? So, let's... Oh, crud. Let's go, let's test out the while loop. So, let's say have a number. We'll call this amount is equal to 10. And we'll have a while loop. So every time it goes through this code, it's going to subtract 1 from amount. So let's run this and see what we get. So now we have a program that counts down from 10 all the way to 1. And it does this because it starts an amount and it subtracts 1 every time amount is greater than 0. And it keeps on repeating this while amount is greater than 0. And eventually it becomes equal to 0, which isn't greater than 0, so it stops. So now this is what a while statement does. Now this is a lot of code, and wouldn't it be nice if we had a convenience thing so we could just do that in like a lot less code? Well, we do. It's called for. So for amount fell. So first we declare a variable for amount is equal to 10. And amount is greater than 0. So while our amount is greater than 0, my shit might be listening. So while our amount is greater than, we're equal to 0, we're going to subtract 1 from our amount. Let's try that. See what we get. So it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And as you can see, that's not good, because we only want it to go down to 1. I don't know why we just do. Well, we'll deal with it for now, but later that could be a big deal. So I'll explain how to fix that in a bit, but let's explain how this for loop works. So as you can see in this for loop, we kind of have three separate statements separated by semicolons. So we first have a variable amount, and we're setting that to 10. Then we have a condition, amount is greater than or equal to 0. And then we have another bit of code, which is just regular code, and it's subtracting 1 from our amount. In a for loop, you need these three pieces, because the first piece tells it the initial start variable. The second piece tells it when it should be running. So this is like the condition in the while loop. And then this third piece tells it what it should do every time it runs. And it just subtracts 1. So that's how a for loop does. And there's more advanced for loops that don't require all three parameters, that operate with arrays. And we're not going to get into them. Well, actually, I might. We'll see. So we have all these new types. We have all these new conditional. We have all these new conditional operators. We have a bunch of new stuff we can play with. Well, what if we wanted to make our own types? What if we wanted to have a selection? Let's say you had a box on a website that said, like, let's say you were making a pizza website and you had a box saying, do you want cheese or do you want cheese, pepperoni, supreme? What do you want? Well, how would you do that? Wouldn't it be rather inconvenient to have an actual text store that has text? Why not, instead of storing it as text, which might take 20, 30, 40, 50 bytes, instead we store every option as an individual number. So that's why we have enums. So let's create an enum. We'll call this topping. And then we'll have cheese, pepperoni. I don't know how to spell pepperoni. I think that's right. And supreme. And each of these is assigned a value. This by default is 0, this by default is 1, and this by default is 2. And you can even have functions in here. So void print topping. And this keyword, it means the current object that code is applying to, because there is certain code that can be, because this is something that a topping can do. It can print what topping it is. So that's printing its current state. Its current state is this. This is the current state of the object that you want to act on. So let's go ahead and get a topping. So now we see we have these three options here where we could choose what topping our pizza is. So we can, topping not cheese. Then we could do food dot print what it is. So let's run that, see what we get. Yay, we got cheese. By default, when you convert an enum to a string, it is whatever option you choose. So if you choose pepperoni, it's going to print out pepperoni. So yeah. Now, let's actually look how this is stored in memory. So we have our variable here in our variables list. And we can see that right there, this right here, ordinal, that's the value of our variable. This isn't really memory, this is just all the parameters of that variable. So our parameter is 0. But it'll also tell us our name, which is cheese. And it'll even give us a hash of our name, which should not be 0. And remember how I was talking earlier about variable, a string just being a bunch of characters? There's all the characters in the string. So that's how that works. And if you're wondering what I've done there, this is something called debug mode, and you might use it later. It's quite useful, but what it does is it lets you view what's happening in your program. So if you got a fairly advanced program and you really just can't find a bug, you can actually view the individual variables and find out, oh, that's adding 1 in extra time, or that's subtracting 1 when I don't want it to subtract 1. 90% of the time you'll be working with purely numbers in programming and generating your text after you've already done all the calculations and information we need to do. So let's create a fairly simple program using all of our knowledge, and we're going to call this the Collatz conjecture, or just Collatz. So, the Collatz conjecture is a thing that... So, it's this function here. So if x is divisible by 2, f of x is equal to x divided by 2. Otherwise, f of x is equal to 3x plus 1. So let's create a method here. Since we're uncreative, we're just going to call this f of int x. I'm also going, I think I may have touched on the return operator, the return types last tutorial. So you guys should know what they are. So if x modulus 2 is equal to 0, what does the percent sign mean? It means modulus means divide it but get the remainder. So that's our f of x thing. So now what we're going to do is we're going to say scanner input is equal to new scanner system.in input.close. This out. How far do you want to go? Input.next, yep. So, what you do with the Collatz conjecture is you can run it from every number from... So, let's say we give it a number 100. Well, we go from 100 to 0, and we find the number that takes the most iterations to get to 1. So now that we've got our input for our user, we're just going to go through that list. We're going to go through and see which number takes the longest. We'll use a for loop. Now, if we do it backwards, it's going to be a lot more efficient than doing it forwards. Because most of the time, the larger numbers are going to take the longest since they're bigger. So we'll go ahead and do it backwards instead of forwards. So now we need to get the length of these. And we'll just go ahead and print these out. There we go. So now for each of these, so while our function of x, so f of x is greater than 1, wait, I could just do x is greater than 1. So while our x is greater than 1, say x is equal to f of x. I'm going to go ahead and run it. Let's see here. 100, number that take, okay. Oh, duh. So and we can verify that number by going to Wikipedia and see 97 with 118 steps. And as you can see, with this program, for, while, and if statements are very common. And I completely botched the spelling of divisible. And you can make some pretty cool little programs. And this whole entire program is under 40 lines of code. And we can shrinkify this program. By getting rid of that. So there we go. And now we made a nice little program that we can, I don't know, do stuff with. And run calculations with. Don't get me wrong, this isn't the best. And so why did I choose this? Because I wrote a really complex and annoying version once. So yeah. So if we look at a really good version and we compare the two, well, it's not the best version. So I wrote one a bit ago, and I done it up to 1 trillion using 100% of my CPU. And it took about a week. We're just going to close that project. And we're going to look at this. So this is a more complex version of this, and well, as you can see, it's kind of more complex. And we're using 64-bit integers, so we're using longs. And this is happening on all 8 threads of the CPU. So 100% of the CPU is used. And in my next tutorial, I'm going to do some libraries. And we're probably going to do threading and maybe some networking. I don't know about networking. That's a little head-on. Or maybe some graphics. I want to get to the fun stuff because like doing types and functions is not my thing. Boring. So, don't overcomplicate it. Don't give up if you don't understand something. Post a comment in the comment section saying you don't understand it, and I'll try my best to read the comments and explain it. And, peace out. Where's this?